Thank you for joining. My name is Mark. I'm going to start with a story. So I used to work at Lyft. And at Lyft, I was in the data team. During this time, Lyft was growing really quickly. And I remember talking to a data scientist who worked in the ETA team. ETA is the time a driver takes to pick you up. And this person had built a new model for ETAs. And ETA and pricing are the two biggest factors that help Lyft make money. And this person had built this new model, and I was chatting with them, like, how's it going? And this person says, oh, well, the model is ready, but I can't deploy it. And I'm like, why can't you deploy it? Because I don't know what to compare it against in my data warehouse. And I was like, why is that? And he made me pull up my app. I was living in the San Francisco Bay Area at that time. He's like, you open the app, it says your driver's 2 minutes away. You put in your destination, like Fremont, California, which is, by the way, kind of like Cedar Park in Texas. No one goes there. And then the ETA becomes like 7 minutes. Then you say, I'm going to take a line ride, and the ETA is 10 minutes, and the driver actually shows up 12 minutes later, right? So even in that session, I've measured ETA 4 times. We've had previous models of ETAs that are all logging data to the warehouse. And there were 20 models in the past, 20 times 4, that's 80 columns right there. This dude had joined the company 3 months ago. So of course, in just the ETA of real data that's being logged in the warehouse, there were 80 options. And of course, they had no idea what was the source of truth, right? And so that pushed me to create a product at Lyft called the Data Catalog. The name of that product was Amundsen. That was super successful. We're going to talk a little bit about that product today. But that product used proxy of popularity to kind of tell you what's trustworthy based on what other people are using. However, that was 2018. And the more time I've spent on this problem, the more I've realized that the problem of solving that problem at the back end, which is using the popularity to drive trust, is actually thinking about it all wrong. And what we need to do is, instead of dealing with this issue later on with all the data we have, we need to go further upstream and try to reduce the hay in our haystack, or drain the swamp so there's easier for the alligators to muddle through. So that is the talk today. I'll start with a little bit of my background. I started my data journey working as an engineer on Spark at Cloudera. From there, I went to Lyft. There's going to be a little more conversation about Lyft. That's where I created that project that no one can say or remember how to spell. That project was pretty successful at Lyft, used by 750 users every week, and called Amundsen. It was then used by Instacart, DoorDash, Brex, Workday, ING Square, many others in the open source. From there, I left to start the next generation of that product, company called Stemma, product called Stemma. And today, we are a data catalog used by companies like SoFi, iRobot, Convoy, Grafana, so on and so forth. Cool. So this problem of data discovery, this idea of the data scientists working on the ETA team, there's a lot of wasted time. And this was an analysis that I did during that time, where the first part of the journey of an analytics workflow is discovery, which is like, OK, I'm going to look at what were my orders last week, and I'm going to find that I need to know where the source of truth of this information is. What do I need to join with what in order to get that information? Then I do some exploration. Maybe I do some data quality, make sure it's in the ballpark of what I'm looking at. Then I go actually write a dashboarding or an analytical model, and then I communicate that model, right? And the thing was that the first 2 pillars there, 35% of the time was being spent in that. What do I need to use? Do I have it? Can I trust it? And a third of analytics time being spent on that felt like it was a huge opportunity to reduce, right? And so that pushed me to create this product, Amundsen. This is a little bit of a graph of that and how much love it got at Lyft. So, there are holidays when you see dips, but overall, up and to the right in terms of usage patterns, analysts love it. There was a Slack channel where there was an on-call person every week. People would just come ask this person questions. Do you have this channel in your company where people just come and ask data questions? Yeah. And then this channel person, there was one data scientist a week that was answering these questions. And that person said, hey, I felt like in the first week, I could answer 50% of the questions just by saying, let me Amundsen that for you. Anyway, this is a little more about the community. So a bunch of these companies I already mentioned. And I thought like solving this problem with Amundsen was solving all the problems, right? And I was wrong. And the reason is that Amundsen used popularity, which is how many queries are happening on a table, to to power ranking. So if all the other data scientists in the company are using this particular column, joining this table with that table, querying this particular table in this way, then maybe you should too. That was the core thesis of the product. But what I found was that more and more data was being generated, and it felt more that the problem, if we had to solve it in a sustainable long-term way, that we needed to control how data was being generated. And that pushed me to notice that in software engineering, we make changes to our software very often, right? You've got some function, you delete that, there's a compiler that compiles it, there's dependency managers who make sure nothing is broken, and then we, every week, if not more often, will delete code. But deleting data is something we don't do, right? And there's a reason behind that. So we did some research, and I'll go into that in a moment. But the process of deleting data is very voodoo right now. And because of that, if you delete data, there's a high chance that there's some stakeholder somewhere who's going to get surprised by it and come and bite you later, right? And that is the real reason I think we are not making changes to data. So there are two perspectives to making changes to data. I'll start with one story. Just last week, I live in a very crappy apartment building in Redmond, Washington. I was taking a shower. I still take showers even though I work from home. And I was taking a shower, and I've got my soap lathered on me, and I'm washing my face, and the water goes out. And I'm like, my eyes are itching. I'm like not having a good time. And then I yell at my wife as to what's going on, and she doesn't know either. And later, thankfully, I managed to somehow wipe my face and figured out by reaching out to the apartment building that there was a scheduled maintenance of this water being turned off from my building. And I didn't know anything about that, right? And the reason the story is relevant is because when we data engineers make changes to data, this is how data analysts feel, right? This is like, oh, I had this model, I was going to go into an exec meeting, I have the dashboard pulled up, but the data is not there. And the other side is the poor data engineers, right? The data engineers, they'll go to the Slack channel where all the analysts are hanging out, and they're like, hey, by the way, next Monday, they're my apartment building, right? Next Monday from 9 a.m. to 5 p.m., we are doing some scheduled maintenance. Or, by the way, more likely the scenario is, starting Monday, this column is no longer the source of truth because we changed our CRM from this thing to that thing, and you need to start using this other thing, right? And not just that, the data engineer told them once on Monday, a week before, they told them once on Wednesday, and they told them once on Friday with big flashy Slack emojis, right? But the analysts didn't pay attention, so like obviously on Monday their dashboard is not working, right? So we have a pretty terrible situation, right? An analyst feeling like you are pulling the rug from underneath my feet, and then a data engineer feeling like, oh, I try to feed you, right? But you're an alligator who comes after me because I told you 3 times I'm going to make this change, and you still didn't listen, right? So I want to give you 2 real examples. Obviously, I won't name these companies, but these are companies we've talked to work with where this situation materialized. So company number 1. What they're trying to do, like a bunch of companies in this economic condition, is trying to reduce the amount of spend that they have with their data, right? By the way, the amount of spend, there's a few different sources. ETL and compute are 2 major ones. Turns out ETL is almost always the largest one. And so like most companies are looking at their ETL spend. They had this table that was costing them a ton of money in ETL. The analytics team rigorously vetted out to make sure no one was using this table. They deleted that table, right? Well, what they didn't realize was that this table was being used by a service account, which was not going to show up in your DBT repo. It wasn't going to show up in your lineage graph anywhere, right? That was a high-touch account that was taking that data, putting that into their marketing system, which was then sending emails to people, right? All this got screwed up because they deleted that table. And in this case, they did all their diligence, right? Let's talk about example number 2. This company had a sandbox schema, right? So we try to do self-serve. And what you do is you end up creating a sandbox for some analysts to go build a table for themselves. They build a table and they always say like, hey, I'm going to only use it for this one use case. Trust me. It's only going to be for this one use case, right? What happens is that use case happens, another analyst finds that particular table and they're like, oh, this is almost what I want. So I'm going to just extend it a little bit and I'm going to use it for my use case. The sad part of the story is data team doesn't know about this. The analyst who may have created this doesn't know about it. It just gets reused, right? And so what happened in this particular case is that this particular table was created by one analyst, started being bastardized for use in another use case, and then off comes a meeting in which one analyst, the second analyst who opened this up, and another person brought 2 numbers to the meeting, and the numbers were wrong, right? So I'm sure we've never heard that before. And data team started getting blamed for providing untrustworthy data when all they wanted to do was enable the first analyst for an ad hoc self-service use case, right? And so what we did was like, okay, there's a lot of pain around this changing of data problem. So what exactly is going on? And we asked people questions in 3 categories. First one was, how often are you making changes to data? The second one is, what tools and process do you use in order to make these changes to data? And the third one is, what is your sentiment around making these changes to data? Which parts do you love? Which parts do you hate? So on and so forth. Here's what we found. We found that data engineers loved spending time on data modeling, solving bugs, scoping out long-term projects, and this is no surprise to anybody. What did they hate? They hated rolling back changes, right? I just made this change, you have to use this table, and then someone says like, oh, how come you made this change? We need to align and talk, and there are meetings, and actually you end up rolling this change back. And the difficulty of making data changes was 3 out of 5. Higher, the worse. But the difficulty of migrating users was 4 out of 5. That means that I can do my work of like whatever new ETL job I need to create. Maybe I pause an existing ETL job. But all you people who are built on top of my table that have like ETL running, dashboards running, ad hoc queries running, reverse ETL jobs running, I got no way to coordinate that. So what ends up happening is just a bunch of Slack messages that get blasted on Slack, right? 20% of them had done no form of impact analysis of who's going to be impacted. It's just kind of like spray and pray, right? And then the stat is not here, but 70% of them just hated the process, absolutely. And so this is what happens. 60% of them did blasts. And so here's an example of what happens. Rob, our data engineer, is like, hey, we're migrating core orders to core orders new. This will affect all exec dashboards. Watch out. Big yelling letters. And then a few days later, Michael's like, oh, I'm noticing my exec dashboard is not working. What is going on? And then there's an 8-message long thread. Rob telling Michael, be like, hey, dude, told you. And Michael's like, oh, I was on vacation. I missed it, right? This is the current process and parts of what works and what doesn't. So the first part is a data engineer scopes out the change. The next step is usually investigating usage. This part almost always gets skipped, right? There are no good tools for most organizations to investigate who's really using my data. Then comes a blast to users. This is the Slack message we saw. And then in theory, the next step is checking table usage. This also doesn't happen. Ideally, what you want to do is you want to send out a message and you want to see the usage go down. And then if it's not going down, you send out another targeted message. And that doesn't happen. So ideally, you want to see check table usage. This is not happening. If the usage is not decreasing, you are caught in that loop. You can't make that change until people have reduced their usage. And a lot get caught in this loop today. OK, so hope the usage is changing. Maybe it's all go down to 0. You execute the change. And lo and behold, you fear that no angry user shows up on the day you made that change. And if no one shows up, your change is complete. And if someone shows up, you go back to square 2 of doing this change again. And this was very common. So The reality is I've talked a lot about this problem, right? But this problem is solvable. And the key to solving this problem is understanding where usage comes from. So there are three kinds of usage that comes. The first one is ETL usage. So this is like your ELT or ETL queries that are generating data. Second one is analytics usage. So it's ad hoc queries being run on your data through data grip to Snowflake UI to so on and so forth. And the third one is machine usage. So this can be usage from ML models, reverse ETL, things of that sort. And so what I wanted to do was I wanted you to walk away with some tactical things you could do to better understand how data is getting used. So this is a query, and there's a blog post at the end that I'll share, which has all these queries as well. But Snowflake now exposes query exhaust to you, which means that you can run a query like this, which will tell you in the last 7 days how many people have queried a given table. By the way, we recommend that you query it for 90 days. Why? Because sometimes the analysis that's done is quarterly, and if you just queried it for 7 days, you will miss out on the quarterly analysis. The second thing is that this only works for warehouses that support this sort of pre-processed output out of their query logs. And there are two warehouses that do that today, Snowflake and BigQuery. So if you're on that, you're good. And if you're not on those, this option is not available to you. Another gotcha to keep in mind is that Snowflake queries have a lot of idiosyncrasies. For example, the data in the Snowflake query logs is only available, I believe, for 14 days by default, which means if you have to go 90 days, you have to accumulate and ETL these query logs into a table of your own and manage that ETL process to have a 90-day enough buffer in order to do that. Cool. So that's one query, ad hoc query usage on Snowflake. The second thing is, if you're using dbt, dbt allows you to generate docs. These docs actually have this lineage graph, which shows you table-level lineage, and you can simply do dbt docs generate and dbt docs serve in order to understand your ETL usage from those. The tricky part about this is dbt docs sucks in performance, and it sucks in user experience. And so it's not something that you would feel proud like passing it on to someone else. And it also is only at table level, so you can't get any information about column lineage. The pro tip here is that you want to delegate ownership responsibility, right? So if you find that I am the owner of this particular thing that I'm deprecating, and there's a downstream owner, you want to pass on the responsibility and trickle it to that person so they can manage their users of the table using some of the same tools that you're using. Lastly, you have to get usage from the BI tools. Now, this is also not consistent, but a product like Tableau offers you an API. So in this case, I'm looking at an API which gives you the list of upstream tables. Given a Tableau dashboard, can you tell me what are the upstream tables that this one comes from? And the reverse of this API, this output, is what tells you what dashboards are built on top of this table. So all I'm trying to say is that if you're using a data warehouse that supports pre-processed query logs, if you're using a BI tool that has an API that allows you to read in pre-parsed lineage parsing for their dashboards, if you use dbt, you can stitch together usage information that's very helpful for you as a data engineer to understand the usage. Tableau API in particular is very cumbersome to use. Most products will not give you the list of pre-parsed tables. So they will only give you queries that are being run by the BI tool, and you would have to do query parsing in order to generate the list of tables. So process in an ideal world, if you had all this information, is you would use the exact tables that are impacted by a change. You would make downstream changes that you can make yourself in the dbt repo, and then you will submit them to review by those owners, right? So I am modifying the downstream ETL jobs and creating PRs for my peers who are data engineers, and I'm also making changes to Tableau dashboards, which are essentially copies because Tableau dashboards are not versioned, and sharing them with the downstream users. And you can automate a lot of this because of the APIs that are provided and make those changes a lot more often, a lot more quicker. And the ecosystem is evolving too. So what you will find is that this whole process of making changes relies on a lot on you in order to do query parsing, look at Tableau lineage. But catalogs like Stemma, the company I founded, actually track this usage across a variety of different tools. And I'll show you exactly in a moment how. And then we also allow you to make changes and communicate these changes to the downstream owners. So instead of sending Slack blasts, you're actually sending very targeted messages to people who own those tables. The second thing that's happening is that their BI tools are going in two categories. There's a category of tools that make reviewing a part of the product itself. So an example here is Hex, which allows you to do a PR-style proposal to an existing notebook. And the second category is where products have APIs to modify dashboards, but there's no construct to do a review, which means that you can create a new dashboard that's a new version of an existing dashboard and ask the owner to compare and contrast. Ultimately, the more comfortable you can get with making changes to data reduces the amount of clutter and lack of control you have in your warehouse and makes the problems around data discovery, data management, data governance, data quality, PII, a lot more manageable because you can very comfortably make changes to data just the way you would make it to source code. So I want to show you some screenshots of Stemma, which provide you an insight into what that could look like in what looks like in a product. These screenshots have been plastered in 3 in one slide, and if you want a deeper demo, it's on stemma.ai. But the leftmost screenshot actually shows you lineage. So this is what Tableau dashboards and what tables have already been built on top of this data. Here you're looking at a table. You see upstream, but in impact analysis, most important to you is downstream. So here you're looking at this column called user ID, which is the filtered by column. And that allows you to see that there's one table that's downstream, and you can see the distance, which is 1 level downstream, how popular it is, which tells you the number of queries that that dashboard has gotten and from how many users. And that's a lot of information for you to be armed with, knowing whether that's a highly used downstream table or a not so highly used downstream table. And that's the first chart on the top left. On the top right, what you see is frequent users. Now, these are your ad hoc users that are querying the table. This goes as far back as 90 days, like I said before. And so you can see any user who's queried my table in the last 90 days, who that person is, how many queries have they run, what source did they run the queries from, whether it was Mode, Looker, Tableau, Hex, something else, and when was it that you saw the query from them last. And that shows up in the frequent users category. And lastly, you can visualize all that in a lineage graph. Most lineage graph in organizations are complex, so they look great in demos, but in practice, they don't work. I have a biased opinion that we have spent a ton of time with customers with complicated lineage graphs and making that work. But in general, what you want to do is you want to be able to filter out a graph very quickly and be able to use it in a very managed way. And filtering out may mean like, oh, I only want to filter at this particular column that shows me all the downstream dependencies for that. And that's an example we were showing in that screenshot. There's more about this on the website. You can reach out to me, mark@stemma.ai. I'll leave you with this one thought. If we could make changes to data with as much confidence as we make changes to software, the problems that are downstream around data quality, data governance, data management become a lot simpler. So if there's one thing you want to take away from this, that's all. Thank you.